Yeah, thanks everybody for coming. My name's Isaac Wilson. I'm an engineer at the trade desk, and today I'm going to talk to you about load balancing. Specifically, what our on-prem load balancing environment looked like, and what our migration was over to Kubernetes Gateway API. Yeah, so for today, I'll give you a little bit of the history of what Kubernetes has been like at the trade desk. I'll walk through what our old architecture was, as well as some of the challenges that we wanted to fix. A quick intro on Gateway API and Envoy Gateway, what our migration strategy looked like, some lessons learned that hopefully you can take away and reuse in your own migrations, and then finally go through some of the actual outcomes and things that made it worth doing. Yeah, so you guys have probably all seen other migration stories in general, but for us, this was a pretty big step. The trade desk, we provide an objective, transparent, and an independent platform for ad buying. What that actually means is if you've ever gone to a website with ads on the side, or if you use a streaming service and there's an ad break, in a fraction of a second, those providers reach out to real-time bidding platforms like ours, and in less than 100 milliseconds, we will run an auction, and effectively, whoever pays the most to serve some content in front of your eyeballs, they will typically win. So that 100 milliseconds, that includes everything from the connection establishment time on the client side, as well as traversing all the network paths in between. On our side, we try to process those requests in under 5 milliseconds. So just to put some perspective around it, most of our requirements are rooted in very low latency needs. And then we also have pretty high scale, roughly over 20 million QPS, queries per second, which may or may not include a single bid request, but I don't want to dive too deep on that. As far as Kubernetes, the team started in 2020. At the time, like many other companies, we were just using it for greenfield applications and just trying to figure out how this thing could work. Since then, we are now running in multiple other cloud providers, and we have a global footprint with I think around 40 or 50 clusters now. And then just last year, we finally finished our expansion into our metal data centers, which is where the majority of our compute is. And that's also where our more critical workloads run. And we have some pretty big clusters and some interesting challenges to solve for. So it's been a fun journey. As far as our old architecture, this is kind of what it looks like. I'm going to start sort of from the bottom up here. And so if you're familiar with Kubernetes topology zones, that mostly translates to a rack in a data center for us. So if you see at the bottom, there's rack A, B, and C. And then you can see the box of the Kubernetes cluster around there, and then the pods that we spread throughout. We use Console for service discovery, for connecting things from outside the cluster to things within. And so that's where HAProxy comes in. It's using a tool called Console Template, which sources its or it has a template, and then it sources its configuration of endpoints from the console server that's running outside. This design has been in place for a long time. It's pretty rock solid. It's well understood within our environment, but it just comes with a few challenges. As you can see, HAProxy is only configured to route to the backends on the same rack, which is mostly for performance reasons, but there are some other complexity challenges there as well. But that forces us to do some things that we'd probably prefer not to do. So jumping into a few of those. One thing is that it slows our rollouts down a bit. So because we're using a tool that doesn't have direct integration with Kubernetes, it lacks the visibility to differentiate between, say, a terminating endpoint versus just one that became unready for a few seconds. So what that means, when you scale up to, let's say, 1,000 different replicas, adding an extra 5-second delay for that pod to stop getting traffic from the load balancer just ends up slowing your rollouts. In our case, could be an hour or multiple hours. So that was something that we wanted to solve. It also requires us to strictly balance our workloads throughout the racks. And that's not just for failure domains, but just to guarantee even traffic distribution. Because again, HAProxy is only routing to the local backends. Thirdly, it's very difficult to make changes to this environment. It's just kind of become a rat's nest over time. So we have a Jinja 2 template that we use within Ansible, and then that gets wrapped in console template, and I believe we have a third one in there as well. So it's just hard to touch, and it's hard to understand. So anytime that we do need to tweak anything, it usually is like a multi-team effort, and it might take a couple weeks or up to a month to actually get that change out. And then that just leads to the next point of we just haven't even been able to onboard any new services besides the 2 core ones that have always sort of lived on this. And then the fourth point, this is mostly because we were running a very old version of HAProxy, but it could only use up to 64 threads. So on some of our larger systems, like we have some that have 192 cores available, or wasting more than half the available CPU. So that was something that we wanted to fix with a new approach as well. And thankfully, the network team let me convince them that we should throw this all away and try something new. And that's where Gateway API comes in. So if you're familiar with Kubernetes Ingress, this is sort of the successor to that API. If you've ever used like Ingress Nginx, or I'm trying to think of a few others, but you're probably familiar with the hundreds of different annotation options that are available, but those don't necessarily translate well between different controllers. So if you want to move, it's a pretty significant effort. That is something that Gateway API wanted to solve. They have a very advanced, they offer a lot of advanced controls directly in the API. And so some of those settings that used to be annotations are now directly exposed. And so that makes it easy to, say, jump from, I don't know, EnvoyGateway to Istio or another controller as well. And then lastly, it's built to be role-oriented. So before, an ingress might include something like the gateway as well as the HTTP route. But now, for your front-end configuration in HAProxy terms, if the cluster operators or the network team or whoever else wants to manage that, they can focus specifically on that, and then the application team can own the way that traffic makes it to their application and set up their HTTP route however they see fit. So this just allows for separation of roles in a much cleaner way. Yeah, so it's been great for us. OK, why Envoy Gateway specifically? So when I was evaluating a bunch of different controllers early on, at the time, there was 3 main ones that we were considering. The other ones were Istio or Cilium as well, because that's the CNI that we use. But for us, like, we noticed that the majority of Gateway API controllers were already using Envoy for the data plane, so we figured we might as well use the one that's under the Envoy proxy org. It was pretty much that simple of a decision, because we figured any feature that was available in a different one could easily be replicated in Envoy Gateway, or if it doesn't exist, we could contribute that back. And actually, that's exactly what we did. We added a bunch of features directly to Envoy Gateway. It's been a great experience. I love talking to Arco and Guy on our Tuesdays. Big shout outs to them. And then lastly, it's just low complexity. So the phrase is simple scales. For us, like, Istio is awesome. It might be perfect for your environment. It's like a one-stop shop for taking traffic to any Kubernetes service. But for us, we may not need all those services, or we might not want to deal with some of the complexity that comes with. And so for us, Envoy Gateway just made sense. So with all that out of the way, we can start talking about the actual migration bits. And for starters, give some background on why migrations are just difficult and usually a bit daunting. So for large changes like this, they usually involve high stakes. So if we have any issues here, that directly impacts our revenue, or we could lose some customer trust. And then also internally, if we mess something up, then it's all of our future changes are going to be more scrutinized. It's going to slow things down, and it's just difficult to move forward. The next one is unknown unknowns. So at our scale, we typically run into a bunch of like novel problems or problems that aren't well discussed on the internet. So it's difficult for us to sort of figure out. And so when we introduce new changes, it's hard to figure those things out without just going through failure. And then the next one is tribal knowledge. Like I said, our HAProxy environment was built up over many, many years. It was rock solid. It was well understood from everybody. And taking that away, and that came with a lot of undocumented changes, or people who might have understand a certain thing, but they've left the company now. And so if we're trying to introduce a new system, it's hard to understand what the actual requirements are going to be. And then on the flip side, loss of that tribal knowledge. When we introduce a new system, everyone has to relearn it. And that's not fun for anybody. And so let's talk through some ways that you can make this successful in your environment. The first one is just anticipate failure. So like things are going to go wrong. You are going to have issues, and you will probably cause some unexpected IMs or incidents internally. Make sure that you have a solid rollback plan instead of just planning for everything going smoothly and rolling things out as expected. Make sure that everyone's on board, and make sure that like you have a good plan to roll this out. Don't treat every data center as the same. There's a bunch of other fun takeaways that I'll go through here later. The next one, try to understand the default behavior as best that you can. So for example, going from HAProxy to Envoy, there's different request timeout defaults. There's different connection time or max connection duration defaults, and a ton of other just unexpected behaviors that, again, you really don't learn unless you just test at scale and just see some failures, or spend as much time as you can sort of tuning that configuration. That kind of takes me to the third one of just making sure that you're benchmarking a proper setup. So what behaves at, say, 1 CPU for 10 QPS is going to be wildly different versus what you might want to optimize around for 1,000,000 QPS for a 100-core system, or whatever your environment might be. So make sure that you're actually validating and trying to tune against what your production load is going to look like. The next one is avoid full cutovers. So don't just YOLO your changes to 100%. Don't just assume that what worked in one environment is going to work somewhere else. Doesn't matter how well non-prod went, or how many green check marks you had in integration. So yeah, just make sure that like if you have the ability to, test with individual customers, consider rolling out like a beta endpoint, consider testing with a smaller distribution of traffic. There's tons of different ways to do this, but this one is definitely very critical. And the most important one is don't do it alone. I made the classic engineering mistake of assuming that it was going to be a lot easier than I thought. And I was like, oh yeah, we'll do this in like 2 or 3 months. It's going to be easy. Well, that didn't happen. And then this also hurts you in the long run by, if you get more people involved early, that pays dividends in the knowledge transfer, having shared responsibility of the rollout, just having more eyes on the change to catch you before you break something. So we would definitely recommend getting as many people as you want involved early. It might slow things down, but just be patient, because in the end, you all want the same thing. So just some 2 random issues that we ended up hitting. Happy to talk through more if there's interest after this. But the first one is how ALPN works by default. So this was in HAProxy, at least the version that we were running, which is now end of life, so should not apply to any of you, had ALPN disabled by default, which meant that most connections would come through and default to HTTP1. However, with Envoy as well as newer HAProxy versions, those client connections will automatically be upgraded to, say, HTTP2. That may not be a problem for your environment, but for us, like, we have some partners who may send a large amount of requests over a single connection after this behavior started, and ending up overloading Envoy when we were doing the initial rollout. So an example here is this sort of jumps back to like not assuming that works well in one data center is not going to work well in the next. So in a smaller data center that we tested with, this just didn't apply because the majority of connections that came through were only capable, or they were just forcing HTTP1. However, when we moved to a larger, newer data center with a much higher level of traffic, this is where we immediately started having issues. And it took us a while to debug because, like I said, the newer version of HAProxy behaves the same. So like it was hard to, like, it wasn't well, we couldn't just like find that documentation line that it's enabled by default. And HAProxy doesn't expose those metrics of like client connection types, and this was just a fun one to dig into. And then another one, I included a screenshot. I know this talk was mostly about our metal data centers, but for AWS specifically, the TCP established timeout for connection tracking settings was interesting. So if you've ever used like Global Accelerator or NLB or ALBs, the idle timeout that they use is somewhere between 330 and 350 seconds. However, if you're just running on a generic EC2 instance, the default is 5 days. And I thought this line from the docs is pretty funny of default 5 days, recommended less than 5 days. Now, thankfully, they did actually fix this with Nitro v6, which is like M8, C8, R8, and basically all of their future instance types, where I think it defaults to 330, if I'm not mistaken. I meant to include that here, but yeah, that's hopefully going to be fixed now. But yeah, that was a fun issue, and we just never hit it before because we would connect backend directly to Global Accelerator. And so by having a larger number of backends, the connection table size was larger, so we just wouldn't have hit this because now we have fewer instances attached. Yeah, that was a fun one. Mostly random. I don't know where I'm going with that. But anyways, on to some of the outcomes that we had here. So why should you consider doing this in your environment? So for some of the technical wins was traffic distribution. So you may or may not remember, but from the HAProxy world, we only routed traffic to the local zone, and we only configured it with visibility to those backends in the local zone. But with Envoy, there's a feature called zone-aware routing, where Envoy is aware of the other proxy instances as well as the topology of backends and their distribution across all the zones. That's a lot of words, but let's say you have 3 backend pods in one rack and a single pod in a different rack. Envoy can intelligently recognize that, and the Envoy instance on the rack with a single pod can say, oh, well, there's 3 over here and 1 here. I'm going to route, say, 25% locally and the other 75% to the other zone, because that has more capacity over there. And that allows us to increase the max skew that we have when we spread workloads throughout the data center, which helps for pod scheduling. It allows us to actually treat topology spread constraints as a failure domain rather than traffic distribution tool. So that's been a huge win for us. And then also, even excluding all that, even when we were evenly scheduled, we still had a wide QPS variance between those different bidder backends. And now it's basically perfect. And so what that has led to is better tail latency. That's led to better resource utilization on the upstreams. And in the future, we could consider doing things like scaling some of those targets down. We could, when we do new data center build-outs, which we pretty much are in the planning phase for every single year, we can have a lower target, and we can just save a bunch more money. That jumps over to sort of the business side of this, where just in the raw compute of what we got back from the wasted the CPU resources before, by making those available to the Kubernetes cluster, that equates to over $4 million in compute savings. You can squint at that, and you can make it like 8 million or triple it even when we talk about pulling workloads out of cloud and running them in our Metal data center, or doing other things like scaling up a different workload so then we can take more bids, or there's a bunch of different use cases there, but it's been a huge benefit for us. And the next one is that we can now very easily onboard other services. And so what I mean there is previously, HAProxy was really only set up for 2 different services. And now teams, it's pretty self-service. They don't even have to engage with us or the network team or anybody else. They can just onboard their app, and they can start taking traffic in Metal on day 1. And it's been awesome. And what that has led to is the ability for one of those 2 teams from the old HAProxy world to already start refactoring some of these monoliths into smaller microservices, and those different teams can sort of prioritize features as they see fit. So overall, it's been awesome. And then lastly, it's a unified architecture across all providers. So what that really means is the complexity has moved from the application teams to us, but at least they have a common experience when they want to take traffic to a Kubernetes service. So it's been great, and it doesn't matter what provider they're deploying to, they have the same experience. So yeah, that's pretty much all I got for today. I know we got a couple minutes left for questions, but yeah, thanks everyone for showing up. Cool. Anybody got any questions? Yeah. Oh, sorry.
Just a quick question. You migrate from dedicated node with HAProxy to Envoy directly inside the cluster, or did you review the sizing of the cluster, and did you isolate some node just to run the Envoy Gateway on the Kubernetes cluster?
Can you repeat that one more time?
Yeah, sorry. You migrate from dedicated node where you have HAProxy to Envoy inside the Kubernetes cluster, okay? Or did you review the sizing of the Kubernetes cluster? Because there is more load, the load balancer are directly inside the cluster. So did you review the global sizing? Did you add some dedicated nodes specifically for the Envoy Gateway inside the Kubernetes cluster, or did you manage it?
Sure. Thank you. Yeah, so our load balancing stack was relatively overscaled to account for spikes in load at random points of the days. But for some period of time, it's safe to basically scale that stack down. So we run our data centers pretty much fully packed. So the way that we did it is basically scale down HAProxy by a certain amount, turn those nodes into Kubernetes nodes, and then run Envoy on them. Does that answer what you're looking for? Cool. Yeah.
So I have a question. So when you're deciding to choose between Envoy Gateway versus the CNI, I think native has a gateway API, like say Calico Gateway or Cilium Gateway. They also use Envoy as the implementation. At least I know that Cilium uses Envoy. So do you notice any difference, or like when you're deciding this, what's your consideration of like which one to use?
It mostly just comes down to the feature set that you need. So Envoy Gateway offers things like Envoy patch policy. So if you want to tweak the raw Envoy configuration, you can do that. They also have a full set of like their own CRDs that you can use to fine-tune that configuration. Whereas like using the CNI-based one may or may not expose all the knobs that you actually want to tune for your environment. So that was really the decision maker for us.
Hey, did you have to run into any sort of edge filtering logic where you had to write any WASM or Lua on the Envoy proxy itself?
Thanks for asking. Yeah, we've actually started on some of that work. So a lot of our traffic shedding is a bit different than what some other people might do. So we can always take on more bid requests. We will always try to process as many as we can. But we throw out a lot of what I'll say like junk traffic or traffic that we aren't going to get much value from. But all of that logic currently lives way in the back ends. So if we could basically shed that traffic at the edge, that's an obvious thing that we want to do. So we've actually started writing some WASM filters. This week just learned about dynamic modules, and I've even evaluated like writing my own C++ filters and a bunch of other things. But yeah, that's something that I'm starting to dive into. That, and then also like advanced load balancing algorithms, like if you've heard of ORCA, Open Request Cost Aggregation. It's a way for you to expose custom metrics from your backends and then inform your load balancer how traffic should be routed. Yeah, that's a quick summary. Good?
The technical question. Can you share details of a sizing of Envoy proxy and how many transactions per second a single Envoy proxy can handle, and what is a transaction means to you? Length, is it like milliseconds or 100 seconds per transaction?
Sure. So just like everything, that will depend on your configuration. So with Envoy, you can tune the connection pool or like the number of threads that are available to it, and that will have an impact on, say, like the number of connections that you can take on, as well as like adding some of the overhead or basically how requests get processed, right? But I mean, for us, like our biggest nodes are 192 cores, and I don't know off the top of my head now, but I want to say it's like, let's say 30K connections per second or something like that. But in terms of QPS, like, I'm trying to think of, I don't know off the top of my head. But yeah, probably roughly 30K new connections per second. And then I know that in terms of like processing latency, like our P50, like the average response time is like, I don't know, maybe like 4 milliseconds or like under 5.
Is it a single envoy per node or multiple envoy proxies per node?
We initially did a single Envoy pod consuming the entire node. We've started experimenting with a few different other options to see what performs better. So in a few data centers, we might have tweaked that to be like either Envoy bin packed with, say, a backend, or Envoy bin packed with another Envoy pod. Yeah, does that answer?
You mentioned having to deal with variability in request rate or like sudden spikes of traffic. Did you have to do any additional tuning around Envoy, like buffer sizes, or with the overload manager that you didn't have to do with HAProxy?
So in our architecture, we had or still have in some places an HAProxy sidecar next to the applications as well, and so that's doing some of the protection logic for us. But to actually answer you, we have basically just tuned Overload Manager and circuit breakers and everything else pretty much up to the maximums that we can support, and we just let all the traffic through. Like I said, like I was answering earlier, like we plan on moving a lot of that traffic shedding stuff to the edge, but we pretty much just over-provision everything so that it's not much of a concern, but that's not a great setup in the long term, right?
Hi. So you mentioned you were using, I guess, console to program HAProxy, and then you moved to gateway. Is that the correct assumption? So like during that process, what was your migration strategy? Because this is a disruptive change, right?
Console is still running inside our environment, and people still use it for different things. But for that specific use case, it was just used to connect HAProxy to the backends running inside of Kubernetes. But whenever we started running Envoy, there is no dependency on console anymore, because Envoy has direct awareness, because it's running inside of Kubernetes, of those upstreams. We use BGP anycast routing, so effectively HAProxy can advertise the same IP that Envoy is, and the migration strategy is basically run them effectively side by side, or migrate individual clients one by one to the new environment to sort of avoid some of that complexity. But effectively, both HAProxy and Envoy are routing to the same backends. I'm sorry. Yeah, the HAProxy load balancing stack is fully gone now.
Question about your deployment. Are you, and what considerations did you take into place? Do you have multiple gateways serving your applications, or do you have a single global gateway which you're configured for multiple routes?
So for our core services, so there's like 2 or 3 what I'll classify as like the important stuff. Those have a dedicated gateway class. They have dedicated Envoy pods to them, and each one of those workloads have a dedicated gateway. And then there's also the other side of it where for the more generic use case, if you're only getting like 10 QPS, or maybe it's some internal service, those we do have a default shared gateway that users can just connect to. And then they just add the hostname header, or not header, but hostname field to their HTTP route, and then they just get all the traffic they need to. But that also doesn't mean that people can't define their own gateway. So if they need session persistence or any other like special settings that isn't available in the default one, they would just deploy their own in that case.
Thank you.
Did you have one? Or? Good. Cool. Awesome. Thanks, everyone. Thank you.